Big thank you to iContact again for hosting this and providing the space. Really appreciate it. So welcome to all of you. Tonight I'm going to talk about sharding in MongoDB. I'm hoping this is a pretty informal talk. If you have questions, please feel free to ask them. I don't think this presentation will be long enough to take us through the whole time, so hopefully get some discussion going if you guys have some questions about it. So I think I'll just get started. I'll say up front, I stole most of these slides from Elliot from Tenjin off of the presentation he gave in San Francisco. So just give him credit where credit's due. He was, I think he's one of the founders of Mongo, so he tends to know what he's talking about. So I figured he covered all the bases, so I just talk about his slides. So this is a diagram of what a complicated version of Mongo might look like. And I want to just talk very briefly about all these different aspects of it here. A very simple installation of MongoDB is just one MongoDB process. And you connect to that, you run your queries, and that's really all there is to it. It's that simple to get it up and running. But anytime if you grow at all and you have any sort of scaling needs or durability needs, you need your data to stick around if the database goes down, that kind of thing, you're going to need to start doing something with replication. And these, something else isn't working on this apparently, but so each of these is a replica set, and each replica set has 3 MongoDB processes. That's typically the way that Tenjin recommends that you set it up. Basically the way it works is 1 is master and 2 are slaves at any given time. And the slaves are just constantly replicating off of the master. So if the master goes down, one of the slaves, there's an election, one of the slaves immediately becomes the new master, and you've got almost no downtime, less than a second of downtime usually at that point. And then, then you're probably running off of 2, but you've got enough time to figure out what's wrong with this one, get it back up, put it back into the cluster, and let it sync back up. And then you're back into a state where you've got 3 replica sets. So that's kind of the next phase. After the first phase is you get one MongoDB running, and that's usually good for development or testing or playing with it. Anytime you're in production, you want to have replicas. So you have probably one of these replica sets. But once you start growing, beyond what the confines of one server or the computational power of one server, at that point you want to start taking advantage of sharding. And that's what this talk is about. Sharding is basically a bunch of replica sets and all of the infrastructure around it that helps you be able to figure out where your data lives on which replica set. So the way it works, you've got little pieces of your data live on each replica set. So in this setup, 1/3 of your data would live here, 1/3 here, and 1/3 here. And you can add more of them as you need. That's why they call horizontal scalability, because you can add more of them horizontally as you need to. The MongoS process here, that's the router. That is what your application will connect to. In this type of a setup. Before, if you just had one MongoDB process, your application would just connect directly to the MongoDB process and run its queries. In a sharded setup, you would connect to a MongoS, and the MongoS router knows, it gets your query, and it knows the data that you want, it knows where it lives, and so it can route you to the right process, to the right replica set. So if the data that you want lives on these 2, but it's not on that one, it's going to issue a query to both of these, and each of these are going to return the subset of data that they have, return it to the MongoS process. The MongoS process is going to combine those 2 and ship it back to you for your application. And MongoS handles other things like, it handles some sorting it can push off to the MongoDB process. It also, it's basically the centerpiece of all of this. It kind of manages everything. Over here we've got the config servers, and the config servers just store your metadata. The metadata is essentially which data lives on which shard. That's there's more there, but that's really the most important thing that lives over here. So you've got the config servers can be in 3 setups, or in 2 setups. You can have either 1 config server or 3 config servers. And almost always you want 3. It would be foolish to run one in production, because if it goes down, you lose all your data. These work a little different. I'm going to talk about them later, but just know that that's where your metadata is held. So a query comes into the MongoS client. It says, where do I find that data? And the config servers tell it, and it then issues the query off to these and then pushes it back down to the client. So that's kind of how sharding works in very, very general terms. So I'm going to go into all of these steps here. Okay, so this is what we talked about. This is a very common setup is to have 3 shards. A shard is also a synonym for a replica set in most cases. So you have 3 shards with 3 servers on each shard, like I showed you. In that case, you'd have 3 masters and 6 slaves. And one nice thing about Mongo, and this is the benefit of horizontal scalability in Mongo, is that as you grow, you can just keep adding shards as you need them. So let's say someday you were hit, a link appeared on Reddit to your site, and you got 1 million signups that day. That's fantastic. Add 10 more shards, and you're good to go. Your database can handle it. It really is that simple. We've done that actually in production where I work. We had to scale up pretty quickly at one point, and we added a couple shards, and it worked really well. Okay, so you might wonder why even bother with sharding. I talked a little bit about the benefits, but this came to my attention just very recently, actually. A company I used to work for, they've got an Oracle database, and it's very big. Basically lives on 1 server. With Oracle, you're kind of limited in that sense. I mean, they've got some capabilities of adding more, but really what you've got to do to expand Oracle is just add more beef to that 1 server. Add more RAM, add more disk, add more processors. And that can become a bottleneck for you if you grow beyond the confines of modern computing. You might need 1,000 processors, and you're going to have some sort of supercomputer to do that, and that'd be a pain. The great thing about Mongo is you can basically use commodity hardware. These shards don't have to be anything spectacular. They could be micro instances on EC2 if you wanted. They could be probably more realistically maybe a large instance on EC2 or something. Or they could be a couple of servers in your closet. They don't have to be anything terribly beefy. And as you need more, you just add cheaper ones, or you add cheap ones to it. So you don't have to pay $1 million to get this massive server. You can just pay a couple $100 to add a couple more servers to it. And there's really no theoretical limit of growth. I've talked to Tenjin about this. I think they said that the largest site that they know of in production is 100 shards. But there's really no theoretical limit to how far you could go. There's probably some practical limits as far as networking requirements and communication and all that kind of thing, but that's a little bit beyond what I know. And then also the fact that it's distributed processing. So if you have, in that case, you have 100 shards, really, when you run a query, each shard is only doing a very small bit of computing. You don't have to use up all the CPU on your 1 massive server for this big query. That's a big benefit. Okay, so one key component of this, of sharding, is the shard key. And the shard key is, it's a subset of your documents, a subset of your document, the keys on your document that identify a unique document in your data store. So you could think of it like a primary key, for instance, if you're coming from a MySQL world or something like that. But you have to give a lot of thought to your shard key. So the shard key is what's used to know which shard your data lives on. So let me use, it's kind of hard to explain, let me use it in an example. If your shard key is username, for users. That's a very common one if you have a users collection. Mongo may put A through M on one shard and N through Z on another shard. And so it uses the shard key to know. So if you get a query for Luke, which is my name, it would know it doesn't have to query the M through Z shard because it knows it's not there. Just based on the shard key, it can only has to query that one shard. It gets a little bit more complicated, and we're going to go into some of those cases. The shard key can be compound, so it could be, like I have down here, it could be the state of the user and their last name. So North Carolina Airsman could be my shard key, and that's kind of what groups me with other users in the database. And there is a requirement for sharding that every document has to have the shard key in it. And that makes sense because it has to know where to put the document. So if it doesn't have that key on it, it doesn't know where to put it. So let me go through an example here. This is a simple user object, a simple user document. In this, there's a couple of potential shard keys here. You could do a compound key on last name and first name. Probably the most probable one would be email. That would just probably make the most sense. But there's some more complicated examples, like if you have a logging application that logs data from different applications and at certain times.